Hello, I am Keke. This teacher guide is about our Mindset Learn series of lessons on gravity and mechanical energy. In this guide, we tell you what the series of lessons is about and how it links to the curriculum. We also discuss ideas for using the lessons with your learners. You may want to make notes, so have a pencil and paper ready. There are 6 video lessons in this series. In these lessons, we investigate why and how things fall and the relationships between mass, weight, work, and energy. In this series, we address the theme of gravity and mechanical energy that fits into the core knowledge strand of mechanics. We have focused on both Learning Outcome 1 and Learning Outcome 2 in this series. The learning outcomes and assessment standards for each lesson are stated at the beginning of each video lesson in this series. In addition, lesson outcomes linked to these are also given for each lesson. The videos demonstrate quite a few important investigations and will give your learners the opportunity to analyze data from these experiments in order to make conclusions. The videos also stress the importance of using the correct terminology. Concepts such as mass and weight are carefully explained and clearly illustrated. These should help learners to recall and explain key concepts. Many different relationships are explored within this topic. Having a good understanding of these relationships will help your learners apply their knowledge and solve problems effectively. The success of these video lessons depends on the way you use them in your classroom. We suggest that you watch the lessons yourself as part of your planning. Decide which videos you will use and think about how to integrate them into your learning program. To get the full benefit of the lessons, your learners need to engage actively with the concepts presented. So, when you preview the videos, think about how to introduce each lesson and what follow-up activities will be useful. Also, watch out for places in the video where you could pause to have a discussion or ask learners to complete an activity or solve a problem posed in the video. We have used this pause icon to suggest some of these places to you. As you watch each lesson, make a note of materials and other resources you might need to bring to the class. For example, you may want to have a packet of sugar for the learners to lift up so they can feel the force due to gravity. Assessment is an important part of teaching and learning, and the lessons provide opportunities for a range of different types of assessment. When you pause the video for learners to do an activity, you can assess their understanding of key ideas in the video and adjust your lesson plan if necessary. The task provided at the end of each lesson is always linked to at least one of the lesson outcomes, and thus provides you with a useful assessment opportunity. For example, at the end of Lesson 1, learners are given data that has been collected from a multiple exposure photograph. They will need to use this data to calculate a value for the acceleration due to gravity. In Lesson 1, we repeat Galileo's famous experiment to show that objects of different mass take the same time to fall. We also use a ticker tape to record the type of motion a free-falling object undergoes. Careful analysis shows that falling objects experience constant acceleration. In everyday language, mass and weight mean the same thing, but in science, these words have very different meanings. During this lesson, we show that weight is measured using a spring balance, while mass is measured using a triple beam balance. We also ask the question, which of these two instruments, the triple beam balance or the scale, will have the same reading for an apple on Earth as it does on the moon? And then inserted a pause button. This should give your learners a chance to discuss this question before hearing the answer in the video. The answer your learners give will give you a good idea of how well your learners have understood the difference between weight and mass. In Lesson 3, we define work. Learners need to recognize the relationship between force, displacement, and work. By the end of the lesson, they should be able to calculate the work done when an object is displaced in the same direction as the force applied. Even though the words work and weight both start with the letter W, they have very different meanings. And in Lesson 4, we show that the force required to lift an object against the gravitational field is equal to its weight. We also show that the work done is equal to the gravitational potential energy gained. The focus in Lesson 5 is on the pendulum. Work is done to lift the bob of the pendulum, and so the bob gains gravitational potential energy. When the bob is released, the potential energy is converted into kinetic energy. We then show how to derive an expression for kinetic energy. Finally, we use the context of transport to evaluate the relationship between mass, velocity, and kinetic energy. In our final lesson, we return to the original problem of falling objects. In this lesson, we revise equations of motion and use these to gather data to calculate the values of gravitational potential energy and kinetic energy at various times during the object's fall. The data we gather clearly shows the mechanical energy remains constant. So we can use this to show that mass does not influence the time taken for objects to fall. We have structured the series in this way to show that our initial experimental conclusions have been confirmed by a theoretical calculation. There is a set of lesson notes for this video series on our website. These notes give a summary of the key points of each lesson and the tasks and task answers. More detailed teacher support for this series, including additional ideas for assessing your learners' progress toward the assessment standard, is also available on the website. We trust this teacher guide has given you a useful overview to this series and will help you to use the mindset resources when teaching gravity and mechanical energy. Goodbye.